Good morning, Year 12. This morning we're going to look at the binomial sign test. Compared to the other tests, okay, this is super easy. So we've left the easiest one until last. So we're going to look at our reasons for using it and how we do it and how we calculate our observed value and so on, just like we've done with the other tests. Okay, so there's our decision tree. As you can see, binomial sign is over here. So if you follow the decisions, you can see that we're testing for difference. Okay, so we've got maybe an experimental design. We've got related data. Okay, it's really important to use binomial sign that the data is related in some way. So maybe pairs of scores, okay, from the same person would be a good indication of binomial sign. And then our level of measurement is nominal. So we've got data in categories. I'm going to contradict myself in a moment when we look at the example. Okay, so there we go. Yeah, those are our reasons. We're testing for difference. We've got related data and the data's nominal. And it's the least sensitive test compared to other inferential tests, okay? So this isn't one that's really going to stand up to scrutiny. It tends to be used just to give you a quick idea as to whether it's significant or not, okay? But it's not really that useful as a test, okay, because it doesn't tell us a great deal. Here's the contradiction, okay. It is used with nominal data, okay, but you could use it with other levels of data. So you can use it with interval or ordinal scales, but because it's not very sensitive, okay, it's best to go for another test. So Wilcoxon would be far better to use, okay, if you had ordinal or interval data. But you wouldn't be wrong if you did use it with ordinal interval data, and they should give you credit for that in the exam, okay. So our example is, so I want you to follow the worksheet as well, and in there's an example of students being asked the question, would you share your French fries with a celebrity or with students from other schools? And so we're going to predict that in response to that question, what students would say is that they're more likely to share their French fries with a celebrity rather than students from another school. Okay, so that's our hypotheses. So our null hypotheses, as per the workbook, would be that there'd be no difference between students in how they share their fries, whether it's with a celebrity or whether it's with students from another school. Okay, so that's our hypotheses. So we're predicting a change of direction. Yeah, it's clear that we're saying that in the celebrity condition, they're more likely to share. So we're actually stating the direction. Okay. So once we've got all that data, once we've got that organised, my slides have got stuck a second. It's frozen on me. Okay, there we go. We've got our hypothesis, so we've got point one. So then we'd record our data in a table. Okay, so there's our raw data. We've got our participants there. There are 11 of them. And in response to the question about whether you'd share your French fries or not, we've recorded a yes and a no. Okay, so participant one asked the question, would you share your French fries with a celebrity? They've said yes. But with a student from another school, they've said no. Okay, so we've done the same for the remaining 10 participants. Will you share your French fries with a celebrity? Will you share your French fries with a student from another school? So as you can see, the data's related. Yes, they're two scores from the same individual. So we've got effect, repeated measures, design. We're testing for difference between the two conditions. Yeah, so another reason why we'd use binomial sign. And then our third reason is that we've got data is nominal. Yeah, we've got the category of yes or no. Okay, so there's our raw data. And then point 3, what we do, first job, okay, is that you need to have a look at your data, and where there's no difference, okay, where they've given a yes, yes response or a no, no, yeah, suggesting that there's no difference between conditions, then we cross them out, okay, so put a line through them, scrub them out, and then at this stage, what I would do is count up your N, ready for the critical values table later. So N, remember, is your number of scores. So we had 11. We've got 2 participants that have said yes, yes, and no, no. So as there's no difference, we're going to forget about them. So we've crossed them out. So later, N would be 9. Okay. So what you then do, point 5, is that you have to allocate what's known as a direction of flow. Okay, so you're adding in a sort of 4th or a 3rd column, and you're assigning a plus or a minus. Okay, so as we've predicted that students would say that they would share with a celebrity and not with a student from another school, then we're going to give that a plus. Okay, so participant 1 said yes and no, so they get a plus. Further down, we've got participant 10 saying yes and no, so they've been given a plus. Okay, where they've said the other way, where they've said yes, I would share with a student from another school, but not with a celebrity, we've given them a minus. Okay, so their direction of flow is a minus. So this is the easy bit. Yeah, you've assigned all your values, your pluses and your minuses, and all you do to calculate the observed value is just add them up. So if we added up our pluses, we'd get 4 participants, and if we added up our minuses, then we would get 5. Okay, so in this case, one of the rules of binomial sign is that the smaller of the two, okay, so are the pluses smaller, the minuses smaller, the smaller of the two would be your observed value. Yeah, so in this instance, we've got 4 saying saying yes, no, so they've got a plus. We've got 5 saying no, yes, so they've given a minus. So our observed value is the smaller. Yeah, so 4 is our observed value. So then we go to our critical values table. As usual, like we know by now, they will give you that in the exam if they want you to do anything with it. And so we're working to 0.05, okay, unless we're told otherwise. We're working to 9 participants, because remember we got rid of the 2 scores earlier in this case. So our critical value in the table is 1. Okay, so we've got an observed of 4, a critical value of 1. We need to acknowledge the rule of R. Is there an R in the test name? Binomial sign, no. Okay, so our observed one, the one that we calculated, has to be smaller or equal to than the one in the table. Yeah, so then you just state your conclusion and rationale. So in this particular example, we haven't got a significant result, okay, because 4 is bigger than 1. So you just need to state that. Yeah, so we're saying that the result is not significant because our observed value of binomial sign is 4, and that's greater than the critical value of 1 at p is equal to or less than 0.05. So we retain or accept on our hypotheses, and then we conclude in relation to what we said in context. So we're saying that sharing your French fries really doesn't matter if you're a celebrity or a student from another school. And that's it, okay? So what I'd like you to do is obviously read through this, have a look at the notes that are supplied, and then have a go at the 2 examples that I've given you. But this one you should fly through. okay, because it's the easier of the 5. And that's nearly our stats journey finished, very nearly.